Well, once again, Algebra Geometry 3 classes, good morning, good afternoon, or good evening. Again, whenever you happen to be watching this, I know now can be a little bit different time-wise when we're all kind of learning on our own time to some degree or another. Well, of the 3 pages of notes, the third page in that first set I've posted on Schoology is actually the 9.2 day 1 notes. And now, unlike when we were just going from exponential form to logarithmic form or logarithmic form back to exponential form, now we will actually be evaluating some logarithms. So again, if you have log base b of a equals x, what I'm even going to do here real quickly is just remind you of our log loop, where we would write that as b to the x equals a. And so basically what these questions are going to have us looking for is what exponent is required to go from a base of b to reach the value of a. And so for all of these examples, like where you have log base 3 of 81, I will always write in an equals x, because basically we are solving an equation. We are solving this for x. So again, we're going to set up our log loop. And so this is going to be 3 to the x equals 81. Now, from here, basically what you're going to do is you can use your calculator if you want, but we have to figure out what power of 3 is 81. And certainly you can, start if you want. 3 to the second's 9, 3 to the third's 27, 3 to the fourth is 81. So you just can kind of work your way up until you happen to find that correct answer. So this one, x is 4. Now, if we look at the next one, log base 4 of 0.25 equals x. Well, again, what we're going to do is 4 to the x equals 0.25. Now, we do run into a little bit of an issue here, and that is if you try to take powers of 4, well, even 4 to the first is 4, 4 to the 0 is 1. My recommendation is, if you happen to have a decimal, convert it into a fraction. If you have one of the calculators that will do that for you, we can rewrite this as 4 to the x equals 0.25 is 1/4. Now, if you think back to our properties of exponents from Unit 8, I know it's been a couple of weeks since we've worked with those. If you have a negative exponent, that's going to move the 4 down to the bottom. So what you can kind of do is think of it as what power of 4 is 4, then just make that negative to give us the power that works. Because if we now take 4 to the negative first and you enter that into your calculator, you will see you get 0.25. So for this one, x is -1. So if you have right here, what happens when is x negative? Well, x is negative if you have a fraction as the answer. Over here I have 1/4. That's going to end up giving us an answer that is negative. Now, if we look at these next ones, log base 1/4 of 256 equals x. Well, I'm going to again rewrite this as 1/4 to the x equals 256. Now, for one like this, again, anytime one side or other is a fraction, that is going to end up meaning we are going to have a negative as our exponent. So what you can do with this one is, instead of worrying about, okay, what power of 1/4 is 256, just look at what power of 4 is 256, and then you can make that negative. Well, if you look here, if I just, again, 4 to the second is 16, 4 to the third is 64, 4 to the fourth is 256. Now, if I do 1/4 to the fourth, I will not get 256, but if I take 1/4 to the negative fourth, I do get 256. So if you watch right here, when I do 1/4 to the negative fourth, it indeed tells me 256. I'll move that so it eliminates the glare. So for this example, x is -4. Now the final one, log base 49 of 7. Again, I am going to set that equal to x. And from here, I am going to rewrite this as 49 to the x equals 7. Now we do run into an issue here once again, and that if you take 49 to the first, it's 49. If you take 49 to the 0, it's 1. So what that basically means is we need a fraction between 0 and 1. And if you even now think back to some of the perfect squares that we worked with in Unit 5, going back to even the very beginning of this semester, the square root of 49 is 7. Well, the square root of 49, if I am working with a square root means I am going to use a 1/2 power. So if you enter in 49 to the 1/2 as an exponent, it indeed is 7. So here x is 1/2. Well, when is x a fraction? Well, x is going to be a fraction when the answer number is smaller than the base. So when is x a fraction? When the answer value is smaller than the base. All right, so as far as these go, if you would like right now, you can again hit pause and certainly try examples 5 and 6 on your own, or if you simply want to watch a couple more examples as I work through them and talk through them, you can do that as well. So log base 1/3 of x equals 9. So again, what I'm going to do is set up our log loop. 1/3 to the x equals 9. Now again, we run into an issue of we have a fraction on one side, so we are going to end up needing a negative exponent. Well, don't worry about the fraction. What power of 3 is 9? Well, 3 to the second's 9. So that means I am going to need an exponent of -2. And then for this final one, log base 16 of 4 equals x. Again, I am going to set up my log loop. 16 to the x equals 4. Now again, we run into a situation kind of like example 4, where the 4 is smaller than the 16. It is going to be a fraction. If you notice, again, we're dealing with a perfect square. The square root of 16 is 4, so that makes x 1/2. Now, going back to something that we have talked about going on the very first day of the notes, if you ever have a logarithm that does not have a base, anytime the base of a logarithm is not there, it is assumed to be 10. I know that on the 9.1 notes, we had told you that's what's called a common logarithm. So if we're going to evaluate with a base of 10, again, I can set this equal to x, do a log loop. So 10 to the x equals 10. Well, what power of 10 is 10? Our exponent's 1. Again here, I'm going to set this equal to x. If my base is not written in, I can always write in a 10 and now set up our log loop. So 10 to the x equals 1 over 100. Now, once again, we do run into the issue. We have a fraction on one side, so that means we are going to end up with a negative exponent. Well, again, if you want, don't worry about the fraction. Figure out what power of 10 is 100, and then you just make that answer negative. Well, 10 to the second is 100, so our exponent is negative 2. And then one final example, log base 10 of 1,000 equals x. So again, if you want to set up your log loop, 10 to the x equals 1,000. And once again, when you deal with base 10, there's a couple of different ways you can go about these. You can certainly use your calculator. 10 to the second is 100. 10 to the third is 1,000. Or a real simple way, when it's base 10, you can look at how many zeros are there. There are 3 zeros, so my exponent is 3. Now, if you are working with a common logarithm and you don't have something involving 100 or 1,000, something that does not involve zeros, if I have log of 8, your calculator most likely has a logarithm button. I can actually do the log of 8 on my calculator. I just press the log button, enter in my 8, close my parentheses, and it tells me it's a decimal like 0.903. Can do the same thing for the log of 0.3. Again, you would not be able to set this up using a log loop. You know, you can't find an easy power of 10 that gives you 8. You cannot find an easy power of 10 that gives you 0.3. So here I can just enter in log 0.3, and again, negative 0.523. I'll round it to 3 decimal places. My guess is your phone calculator, if you turn it sideways, will most likely allow you to find that common logarithm. But now that we have gone over these 9.2 notes, these would actually allow you to complete both of the 9.2 day 1 and 9.2 day 2 assignments in Schoology. They do have some review questions that pull back information from 9.1 as well.